Good afternoon or morning or evening, whatever it is, wherever you are, everybody. Thank you so much for joining us today for the DTV Audio Group Cloud Audio Production discussion. We're joined by some really amazing experts in both the technology and operations of audio production in the cloud. And we're looking forward to it. It's been a wonderful year for, one of the good things about the last 15 months has been all the innovation and the ability to take risk. And I think we've really challenged the workflows and really tried things, been willing to try things. And one of those things is more production in the cloud. And we leverage the cloud a lot for OTT. All of Netflix is built in the cloud. Lots of our regular operations happen in the cloud. But what we're starting to see now is the sort of migration further up the supply chain to take on more and more production, and for the capabilities of that production to be more complex. So I think we're going to start by trying to put some of that into perspective. And I again want to thank you all for joining us. And I think I'm going to call on Tom Zahara to give us his thoughts on that.
Thanks, Roger, and welcome everyone. I thought I'd take a couple of minutes to kind of give the background of why is the cloud important, and what is this interest that we keep hearing about from our boardrooms and the senior levels of management. So with the pandemic really accelerated this movement into the cloud and this virtualization of workflows. Much of it was driven by this thought that the cloud would reduce cost. And while that is somewhat true, I think the past year and change has really shifted that focus away from cost and more to flexibility and rapid iteration of products. As you know, many of the major consumer media companies are going direct to consumer with their streaming products. You have Peacock, HBO Max, ESPN Plus, Disney Plus. All of those are going directly to consumer. And one of the things that they're looking at is really providing exactly what the consumer wants. So this personalization of that programming is really important because they want to attract a wider group of consumers than they can get with a very narrow single channel. So they want to be able to create many different channels in a very efficient manner to capture and hold as many viewers as they can. So in the boardroom, it's all about products, right? All about productization and how can we attract and hold customers. So the cloud really does provide that. It's, for one thing, it's got global reach. It's a global distribution platform. So you're not limited by territories. In many cases with distributed productions, the cloud is actually the closest point between all parties. So it really does make sense when you start looking at this distribution of the workflow. The cloud really becomes the right platform for this. So that's the justification that I see and hear across the media companies. So I'll touch on some of the productions and give you an idea of what these effects may have on the different tiers of production. So at the top tier, the main tier, the Euro 2020, UEFA Championships, Super Bowls, you're probably still going to see your traditional TV truck in the compound, just because the cloud's not quite ready to accept that level of production. But there are many add-ons to those shows that are well suited for the cloud, like social media productions, studio shows, sponsored channels that revolve around those events. Those are ideal opportunities to use the cloud. For one thing, you don't have to travel many people because you can facilitate that in the cloud. You can utilize your own facilities so you get better utilization of people because, again, they're not traveling, they're available. So you get higher utilization of people. And because you can use a distributed model, you have a wider pool of quality talent available to you. So in tier ones, there's still a lot of opportunities around the main show to utilize cloud and cloud productions. Stepping down to the tier twos, you have the colleges, the minor leagues, the semi-professional that don't have the big budgets, but they still want to produce quality shows. And so again, using the cloud allows them to do that at a cost that they can manage. They just don't have the kinds of resources that can build a full out facility. So this lets them start slow and build audience. And as they build audience, they can grow their capabilities. So again, that flexibility is really key to the success of the tier twos. You can start at a level that's comfortable and reasonable and grow as your audience grows. What's really interesting are the tier threes. And that's the small colleges, the high school, the semi-pro leagues. There's a company, Pixelot, that builds a camera system that does some automatic video camera cuts. So you don't have individual cameras, you have a camera module that you can use to cut out several different camera views. They have done over 1 million live events. So just looking at the opportunities, they said, according to their survey of the marketplace, your tier ones are about 1% of the events that are out there. So 99% of events are in tier two and tier three. So when you look at the opportunities to grow, certainly that tier two and tier three presents huge opportunity for growth. And having your production capabilities built in the cloud falls right into the sweet spot for those types of productions. It's a little challenging now, but technology is getting better every day, and we're going to hear a lot about that from members of this panel. So again, I just want to set that stage up, and as we dive deeper into some of the technologies and some of the projects that our panel members have done, you can start looking at how that can open up the opportunity to grow productions and to continue to expand the reach of our production community. So anyway, look forward to hearing the rest of what our panel has to say.
Thanks, Tom. We're going to keep on this note for a minute and talk to Mark Stevens a little bit about how these capabilities in the cloud have expanded. And I think we'll dive into some of the sort of existing audio solutions that major broadcasters are using, and then kind of get into the more cutting edge stuff. So I think we'll throw it to you, Mark. This has been, you've continued, AWS has continued to sort of absorb more and more of these workflows, and the capabilities that are available for what somebody can do in AWS seem to be continuing to expand. You want to bring us up to date on that a little bit?
Yeah, sure. And thank you. Appreciate the opportunity to speak here. My role as a solutions architect is to work with partners in the cloud. So, like Mike Cronk and Grass Valley here, and others, like it's my role to work with them to build these remote production or sound or other workflows in AWS. And I think one thing that's always been great about AWS and what I love is our customer obsession. So when someone comes to us and says, hey, this part of my infrastructure is really difficult. Like, I don't want to have to run an SRT or a Zixi receiver. They say, hey, what can you do for us? And if you look at the way we've been innovating, right, we came out with Media Connect a while back. And Media Connect is that way that you don't have to run your own infrastructure for a receiver that has failover if you're bringing in audio or video to the cloud. It supports things like Zixi, RTP, RTP with FEC, RIST, SRT, those sorts of things. We hear customers saying, hey, well, that's great to bring, these feeds in, but what if I want to do like a horizontally scalable infrastructure for, say, a switcher or something else? Like, then I need something slightly different with like 8 milliseconds of latency, right? Or a frame. Hey, AWS, what can you give me there? And that's where we built something called Cloud Digital Interface. And CDI is really there for transporting uncompressed video between applications in AWS. And these are sort of the early iterations of some of these products. And it's, to me, really fun and interesting to see partners and other customers adopt these so that they don't have to focus on what we call the undifferentiated heavy lifting, right? They can focus on just building the features that their customers are asking for. So those are some of the things that are important to customers. The other thing too, and like, for example, with Grass Valley, we worked a lot with like GPU, right? If you're going to be doing these sorts of workflows in the cloud, we started with a G2 instance. We moved to a G3 instance. Now we're on the G4 and going to be working on the next instance. So, I'll just give an example. Like with the G3, we heard it's great, it's powerful, it's fast, but it's a bit expensive. And it doesn't have like local NVMe for caching. That's where we came out with the G4, right? Lower the cost, improve the efficiency. You can pack more on the instance and then scale out from there. So, that's sort of what I see our role in all this, and always love hearing feedback from customers, partners of like, what else can we do to continue this in the cloud? And it really has been an amazing year, right?
Yeah.
We've been kind of pushing this for years. Some have been dipping their toe into the cloud. COVID came and it was just like, we kind of got slammed with interest. And, partners, customers, all took to that challenge and moved workloads. And it's been great.
Yeah, well, fantastic. And it seems like what we've seen, though, is this sort of migration of the types of solutions around television production. I mean, and this is going back a fair number of years, is you've managed some services, but it seems like the range of things that people are doing in the cloud is sort of expanded significantly.
Yeah, right. One thing that comes to mind is if people saw the HPA found Lederhosen project. When they did it last year, it was maybe one production. This past year, it was multiple cities, and multiple teams. It was like Mexico City, Dubai, Brisbane, LA, London, Mongolia, right? Separate teams, all doing like content production on set, right? And bringing content into the cloud. Like more of an expansion, like you said, Roger, into like, what else can I do? And I think sometimes people look at these workloads like they did broadcast many years ago and go, are you sure I'm going to be able to do that in the cloud? Isn't the latency going to kill me here? But people are finding out that there are bits and pieces of this you can move now, and the latency is great, and you can reach a wider audience or the talent where you need them.
Well, I think there's a couple of, and Tom touched on this, there's a couple of misconceptions, and one of which is if you're on the network, if you're on a telecommunications network or your network, for instance, AWS's network, the cloud is the closest place in time to everywhere. So rather than pull everything back down to an endpoint, if you just go to the cloud, which is sitting on the network, it's going to be closer to everywhere. The other thing I think, and I know you run into this, Mark, is this sort of, and a lot of us have talked about it in the last couple of weeks in preparing for this, is the confusion between latency and synchronicity. David is nodding his head. Synchronicity is critically important. And latency is important for in-ears, for self-hears and things like that. But the audio is going to get there a whole lot faster than the video, and it's going to be buffered and be ready and waiting. And if it's properly time aligned, that's what matters, is that everything needs to be synchronous.
Correct. Yep.
And so there's kind of two misconceptions, which is that going to the cloud introduces latency when in fact it in some cases reduces latency. And the second, that latency is important. And there are lots of stuff. I mean, Tom, you deal with golf a lot and whatnot, and you just got wireless cameras in golf. Well, everything gets pushed back to align with the wireless cameras. I mean, that's sort of normally how you do things. Synchronicity is important. Latency, not so much. Well, Mark, we'll let you go or come back for the Q&A and whatnot. But I wanted to kind of jump over to talk a little bit about getting down to audio now. There are a lot of processes we do now, or some of us do now, with audio in the cloud or in virtualized processes, I should say. And I wanted to talk to Anthony a little bit that Eurosport has kind of really pioneered doing some audio processes in virtualized data centers in your broadcast centers. Anthony, do you want to talk about that a little bit? The kind of things that you do in virtualized audio processes.
Yep. Good evening, everyone. So we have Eurosport Discovery has two data centers in Europe. One sits in Hilversum in the Netherlands, and the other one sits in London. And we have built an our Automix. We have built our Automix platform on a virtualized environment, which sits on a VMware platform. And we are running the Llama application to do all our Automix for the event-based, what we call the event-based commentary. That means that, for example, in the last Roland Garros, which has just finished, we have added for our OTT platforms, we have added commentaries on all the 16 courts available on the digital, on Eurosport and D+ for the Nordic countries. And we can't have, when we have 12 or 13 languages commentating on the 16 courts at the same time, we can't have, that would be quite useless to have an operator for each of these mix. So we are running the Llama Automix platform, totally software. We have merging virtual AES-67 drivers on the network to be able to interconnect with all the 100 booths that we have in Europe and our 256 SIP codecs for the our home remote commentary system. So all the commentators connect to this platform. We do the Automix, and then we push it to the playout.
Anthony, give me the numbers again. How many commentators at once are you doing typically, like with the Roland Garros?
Roland Garros, that was on the two main courses, that was 13 language, so that's 26 plus the side course. Not all commentaries were done at the same time, but that was between, let's say, 50 and 60 commentaries at the time on the let's say busiest days.
Wow. Right. Amazing. Amazing.
So we put all that on the network, all these automix, and then the linear channels can just come and pick as if it was a host feed, you know. But you can, when you pick, let's say the court one, you have available on it. We have a monoclean com with all commentaries auto mixed, leveled, sweetened, but without any international sound, so we can record it for, let's say, editing purpose at a later stage. You have the full mix available. So any production room with a mixing console where you are running a big show can go from court 1, court 2, court 3, and could have already the mix available on the network from this platform.
Wow, unbelievable. Well, and there's just no way you could scale that without tools like the Llama Auto Mixer. And
that would, on hardware platforms, that would be
and yeah, being able to run up as many instances as you need in what I imagine is not a whole lot of rack space.
No, that's a very few rack space, because we run a lot of VMs. We run a lot of machines on the VM platform.
Yeah. And this is, you know, I mean, we talk about the cloud, and I, you know, titled this session "The Cloud," but this is an example of a sort of an on-prem cloud that you're running these sort of things in VMware. And if you wanted to, you could be running it in the cloud. Do you see, in terms of, and this is a lot, obviously this is mostly what you guys do, is you're adding commentary to Nat Sound. Do you see in the future, do you see doing more in these sort of virtualized audio applications, or?
Yes.
Yeah.
I would say probably we have our what we call the PAN platform, which sits on hardware devices, to add the 20 languages of Eurosport on our linear channels, essentially Eurosport 1, Eurosport 2, but also all the other, let's say, children channels. Today this runs on a central audio core, which is also in these two data centers, and that's all remoted from the local countries, because there's no one better than a Bulgarian operator to double check the Bulgarian commentary, check that he's talking on the right game, because that's an issue that we can have when you run so much commentators on so much different events at the same time. At one point, you can have a routing issue, and one commentator can be driven on the wrong feed. And to be honest, for my part, when a Bulgarian talks about one tennis game and this is the wrong tennis court, I cannot feel it. I cannot see it. So that's why we need to have, let's say, audio operators at least monitoring the feeds. But that will probably be the next evolution, meaning that for the linear channels, on at least at the first step, adding only on a produced international sound, adding the local voice, that will be the next step. That running this mix on controlled by a local operator or not, or in an automatic mode, I mean, but that will probably be the next step, that going into a virtualized system. And then the big advantage is that you can switch on when you have big needs during, let's say, Grand Slams, Olympics, or large events. You can switch on a lot of machines, and when you don't need them, you can just switch off. So that's the power of being able to scale is really key in that one.
Scale up and scale back down, and
yeah,
use the resource
that's really important.
Else. Yeah. You know, whether it's on-prem or not, you can be doing live mixing during the day and be rendering something at night. You know?
Yeah.
So.
And then the step after would be when you have large production, a large mixing desk, when you need to have an operator, because there will be a live touch, there will be an interview, there will be a mix zone, then we'll go back to the feed, and etc. You need an operator to be able to do that. Right now, the automix, and maybe in the future, artificial intelligence will be able to deal with it. But right now, we need operators to do that. But that's the same for us today. All the audio cores are in our data centers, and the guys who are in the operator who sits in a PCR in Munich has just his mixing desk, but it's network connected to the data center, and he is remoting the audio core. And for his point of view, for his perspective, when you move the fader, the sound goes up. If it's on a physical device or if it was on a virtualized production system, when the systems will be, let's say, powerful enough to be able to drive really big DSPs and audio mix, I don't see any blocking issue to do that in the future.
Yeah. Yeah, and it doesn't matter where you are. Yeah,
For sure.
Sure. Well, it's really fascinating, and you mentioned AI, and it just seems like there's so many great opportunities for once you're in a virtualized environment like that, then to add on language recognition and other kind of AI stuff. I know we're going to talk about, you and other people are going to talk, Rob, we're going to talk a little bit about AI. But Anthony, that's great. That's just amazing. And the amount of stuff, I mean, you talk about all those courts and all the different languages you add, the amount of content that goes through your facilities is just amazing. So anyway.
Scalability is absolutely important because, for example, we are currently working on planning the next Olympics. The next Olympics will have the most busiest day. We'll have 45 concurrent events. We have 20 languages in Eurosport. Let's say that 12 of them will most likely do commentary at the same time on all, but probably not, because they won't be able to find that number of commentators, but at least they asked us, we want to be ready to do it.
Like 200.
Okay. Yeah, we are planning to be able to run almost 400 mixers at the same time. So the virtualization of the system allows us to we have permanent mixers that Iwan kindly sold us, and we have a deal with them saying that, okay, can we rent some of the licenses on a temporary basis just for the duration of the games, and then we are able to grow up to 405 or 500 concurrent mix if we need to.
And are those commentators all over, or?
They are all over Europe, essentially. And for some of the events, we have some in Japan on cycling events, but essentially on the, let's say, main core of Eurosport, the commentators are in Europe. And we have drastically decreased the number of commentators going to Tokyo because of the pandemic.
Right, sure.
So there will be all a lot of them will be commentating from home, some in booth. The commentating from home during the next Olympics will be a bit challenging, because doing commentary on a sport event when you are in the living room with the whole family sleeping behind you may be a bit challenging. So we are renting some meeting rooms from them to be able to come and join together and not always be at home. But
well, I think we're going to see more of that, is like just empty office buildings and stuff like that, moving people into facilities that are convenient to where they are, but not necessarily their guest room or their loft. Anyway, well, Anthony, thank you so much. I know it's late in the day in Paris, and we appreciate your joining us. It's really interesting to look at the Eurosport is just such an interesting organization. And so anyway,
thank you very much.
All right. Well, thanks, Anthony.
Thanks, bye.
Yeah. Hey, Alex.
Anthony.
How's it going, man? Speaking of loft, you're in your loft conversion.
Yeah.
You have an event coming up too.
I think obviously we've kind of touched on quite a few things there, really, which are kind of common themes across the board, really, in terms of kind of distribution of feeds and kind of the way that we're kind of sharing audio and feeds over the cloud and over the internet, basically. I think kind of I just wanted to touch on what we're kind of currently doing in terms of kind of virtual production at the moment. So we've basically set up a virtual production suite kind of about 4 or 5 months ago now, where we're taking in up to 8 cameras, normally kind of between 4 and 5 cameras, so from a remote OB into the cloud using public cloud system that allows us to stream out onto the internet with some level mixing, level control within instances that are spun up as required in the cloud. So the key locations around that. So we've got the truck at venue, and the local communications embedding for that is happening on site, and that's then kind of basically transmitted up to the cloud via public internet. Got the reporter on venue, and our director and co-director are back at Sky with TS, and the audio communications person is also effectively on-prem, but we've also set that up so that all of those roles could basically work distributed from home, given kind of like moving some kind of screens and basic equipment. So that's kind of like the basics of kind of how we've set the system up. And fundamentally, it's kind of offered that flexibility, I think, in kind of like the way that we're currently working to kind of allow people to kind of work from home or in different scenarios, and to scale the system also as required. So the system's effectively set up in a way where we're taking in their NDI feeds from venue, and then their AES67's basically handing off from the Simply Live system to the audio mixer Reaper that I think we've previously spoken about, which is a door basically. And we've basically got feeds going into that where, from an audio mixer perspective, there's some level control. We've experimented with like level control naturally mixing between kind of reporter mics and kind of commentary mics. And then also the system works in a way where there are kind of virtual snapshots basically, which also control the system. So that's kind of like how we've set it up. And we're taking in, I think, probably close to about 10 mics from venue. So that's effects mics and reporter mics. And then on top of that, we also have our commentary team at our base on-prem. And we use virtualized codecs to get that into the cloud. So I think that's kind of like the fundamentals of kind of how we've kind of been using the system. So I think some of the challenges really around it have kind of been around interoperability, and then just kind of streaming certain like instances and getting them to talk together with different audio flows. So when you're kind of increasing the amount of audio flows over the system and PTP, and then obviously we've also touched on sync, and that's also something that's kind of been varying, to be honest with you. So it's yeah, that side of it has definitely been a challenge, because it seems to kind of change from venue to venue, week on week. I think kind of the way that we were thinking that the kind of evolution of this is definitely something we just touched on, really was around like the multi-channel wider bus count side of it. So potentially kind of once the stereo kind of side of the workflow is nailed down, increasing that out to kind of cater for wider bus counts really. And also potentially kind of sharing DSP is another kind of thought really.
Right. Well, if you talk about the sort of high profile stuff you do now, I mean, most of that bus count, most of that stuff now is Atmos. So you're talking about 10 or 12 buses, 10 or 12 logical channels per channel. I mean, what's the sort of laundry list of what do you need to go from this kind of a pilot project or whatever you want to call it? What do you know, what do you need? Because it seems like you can get a little stereo mixer and that you can do continuity. You can do the stuff that Anthony's talking about, adding something in, and that's a lot of what we do. Or you can break down the mixing task. But when you really talk about full-scale production, it seems like there's just this order of magnitude or two orders.
It's huge, isn't it? I mean, it's massive when you kind of compare the two, and I think it's down to kind of DSP and fundamentally what's available within the kind of systems that have been developed. I think we kind of.
I don't think anyone invented Reaper to use it as a live.
No, so
mix.
I think for us, we just kind of have basically kind of been using this to establish kind of the workflows and ways of how we would do this in anticipation that there would be developments within the kind of vendor sector around this.
Yeah, well, hopefully it's interesting how far we've got, you know. So do you see, I mean, do your team sort of see this doing full scale production? I mean, it seems like the video side of it has moved pretty far, pretty fast. Do you see audio catching up, and do you see kind of virtualizing the back end of a full scale production?
I mean, I think there's a possibility for it. I think it's probably at the moment I kind of look at it and think it's probably a hybrid kind of way of doing this in terms of kind of how you'd stitch all of the kind of audio streams and the different pieces of kit together, from controllers to kind of monitoring and overall kind of control of the systems. I think they're kind of, when you start to scale this, you need to be able to control things on a larger scale. So at the moment, it's obviously, you know, in development, but I think we do see that.
Yeah, well, be interesting to see. And I know, you know, back at your friends back at 30 Rock, they have a sort of virtual control room project that's sort of the same, you know, same idea. But it's easy to say, well, even if it's on-prem, maybe I want to run that as a VM and allocate those resources to something else. There, we're only doing the Today show in the morning, and then we can do, you know, move on to something else.
I think that comes back to the kind of scalability, doesn't it, and the kind of use cases of the systems, really, because if you can kind of join systems together, it kind of opens up collaborative work pieces and kind of ways of sharing systems in ways that we didn't really kind of maybe envisage previously. So there's definitely kind of growth there.
Well, that's great. Well, thank you, Alex. David, I jumped past you, David. I did that intentionally, but I forgot to tell you.
You're all good.
Anybody, David, you've been doing this for a while. This is like old hat.
We love the cloud.
Well, you were in the cloud. You kind of were in this virtualized environment already. I mean, they're freaking video games, you know?
Yep. We get a cheat where we don't have to film reality. But yeah, we've been in the cloud since day one. Our transmission stack has been in the cloud. Our MAM's been in the cloud. But with COVID, we moved our production to the cloud. Our company took it really seriously. There were only a couple, like 50 people that were like allowed on campus originally when it first started. So we had to go all in incredibly fast. So currently we have 6 shows that are fully produced in the cloud. No REMI. There's no owned and operated gear in a data center that we're remoting into. It's all cloud providers like AWS. We are in multiple regions. We do 4 shows with like traditional A1s. 2 are full audio files video. Large shows can have up to like 9 talent. We have interviews, replay, the whole shebang. I think the actual source count, when you really bring it in, it's like 50 some odd inputs that we have to diversify and spread out because of the limitations of certain vision mixers and all that, where you can't get that density anymore. All of our talent is remote. They're all at their houses. So they're doing remote contribution through OBS using SRT into our infrastructure. So when we say we're doing cloud production, we are truly spread to the wind everywhere. All of our operators are working out of their house. So that's our current foothold. One of the biggest things that has lacked since day one is always audio. Because again, we're using vision mixers as our audio control plane. That means it's always been the second thought. So right now we're currently on vMix. The TD's in vMix. He's cutting the show, so the A1 has to remote into it. He gets remote MIDI into it, and he gets soft panels. If there's no API control, he doesn't get that dynamics control. And we have some really good crew members that work well together and can get the job done, but it's growing pretty tiring at this point.
They're not happy. They're not.
Yeah, they're looking forward to having more than 8 faders or having direct access to their dynamics or bus control, which then gets even farther that like the A1s really don't have like preamp control and stuff like that, where in a traditional studio we would have that. And then the biggest thing that is just in a traditional studio, they're integrated together is comms. Comms is a million miles away. It is a separate system. So the magic sauce for our show is everybody's communicating in real time on comms. The video and audio gets delayed to us by 800 milliseconds and we produce the show, but the talent is having an intelligent conversation in real time on comms. But we have no direct IFB foldbacks. If they need to talk to production, they got to mute their production microphone, not their comm microphone. So you get into errors and a bunch of issues roll that way. So those are the big things I'm hoping that come in the next iterations are those true kind of connections. I love like a Glen Sound or Studio Tech box at my talent's house, so that control plane. The other big one is that control plane where I know where my receivers are, I know where my senders are, and I can do the normal XY route instead of having to go to that box and go, what have you latched onto the network? Because the great thing about cloud is everything's always available, but you don't know who's subscribed to what, who may be overloading their inputs or cross-connected, and then you have to go hunt and peck. So there's not that grandiose, I can go look at my router, I can go look at my audio DSPs and go, oh, I know what's going where and I can fix that. So those are the major ones. The other one too, Roger and I were talking about a bit earlier, is latency. For the most part, I think we need a re-level set where latency's at, that we can produce a very competent show with like 800 milliseconds of latency coming to us from like sources. But like communication needs to be under 100 milliseconds. Like how long does the frame need to process? All of that kind of stuff. In a studio, you're just like as low as possible. I want real time, I want 0, I want 4 milliseconds. And we're finding there's a lot more wiggle room in that equation nowadays.
Yeah, yeah. And that's something that I think what's real time, it's a question that production people need to get their head around, is sort of what do you really want? And nobody wants the audio to be out of sync with the video, but that doesn't mean that the audio has to get there super fast, because there's a lot of other shit going on.
Yep.
What
stability is a big
yeah,
tipping point there.
So David, you imagine this is never going to leave the cloud. This is, so you need more audio capabilities.
Yep.
I think this is the kind of question of where do you kind of what's on your wish list?
Yeah, so we're definitely not abandoning the cloud. If we got to return back to normal tomorrow, we've actually seen so much cost savings, flexibility. Like, again, everybody says the cloud can scale. And even more so, the cloud can scale more than labor. The constant problem you guys kept saying is, I don't have enough operators. I don't have enough commentators to support that many regions.
When you need 400 of them.
Exactly. But the cloud can be like, yeah, I'm ready to go. Just swipe your credit card. But really, the next thing is, yeah, I need the equation in like a studio is the machine room's doing all of the work. You have KVMs that go back to that. So that's all your compute. But with cloud production, you're going to have to kind of scatter little bits and spread it out a bit, because like you can't have a traditional console because you may actually have preamps in people's homes and stuff. So things kind of have to spread around, but really getting a proper broadcast audio console. And when my brain, the way I wrap around it, is like a vision mixer is a lot of ins, some outs. An audio mixer is a lot of ins and a lot of outs, all the IFB foldbacks, all of the region support, your ISO records, your mix minuses for post-production. Audio supplies so many things. And right now, I have like, what, 8 buses? I have my master and 7 mix minuses. We're getting by, but like that's not really supporting. I constantly have to go, sorry, we have a limitation. And I really need the A1 to have that control and not just be a board op like he is right now, but go back to being a real audio engineer that is routing and supporting and in control of that.
Yeah, absolutely. Subgroups with dynamics, multi-channel support, monitoring for that.
And like Alex said, people are getting away with like DAWs, but DAWs are not broadcast consoles.
Well, I think, you know, we have better interim solutions, but we still don't. I mean, a regular run-of-the-mill broadcast console is sort of in the range of 1,000 paths.
Yep.
I mean, that's not unusual. And in fact, that's sort of about the level that you start at. Once you have a bunch of inputs that are 5.1 or at most 5.14 and a bunch of microphones, stuff like that adds up pretty quick.
Yep.
So, well, it's interesting. It's interesting. I think it'll be interesting to see where it goes. And as I said, I think that a year ago, I don't think that people were aware of what the requirements were. And I think when I talk to people in the audio community, it's like nobody was aware that people were doing stuff in the cloud. You know, I just think that nobody understood the scale of stuff that's going on. And it's not just esports too, that there's a lot of small events now that, you know, people like Jeff Butler and those guys are just doing all kinds of work that's just not big enough to roll a truck on, you know? So, well, I think we're going to thank you so much, David. I think we're going to jump to Mike and talk a little bit about, and Mike, you were thinking you might share your screen. I don't know.
Yeah, I'll do that.
I mean, this may have, first of all, hold on. You kind of pulled everything forward because of the pandemic. You were thinking with AMP, you were thinking of master control kind of applications and stuff like that. And then suddenly people wanted everything now. And then they wanted audio, and you hadn't even audio wasn't even on your roadmap really, or they wanted more sophisticated audio.
Yeah, so we had introduced AMP with David and Vizrt. You know, kind of our first on-air event was Master Control, and they're still rolling trucks in February of 2020 to various arenas, and we were taking program out and doing Master Control, and that was great. And then March came along, and it's like, oh, we can't do that anymore. And so it's like, how do you do breakaway audio in our Master Control, mixer? We're trying to figure out these like fundamental basic stuff. And so we had some Band-Aids that help, clients like Vizrt kind of get through, but, still there's, other solutions like a vMix, like 16 channel kind of thing. There's some things that it could do. So, okay, just do what you can to get through 2020. Our original plan was by the end of 2020 to add additional production features, and some of the key ones that have come out is that you can take a K-frame panel, and instead of talking to kind of hardware vision mixer in the next equipment room, you can spin up the service in AWS and just talk to it. And so customers like EA Sports, for example, you mentioned Jeff Butler, they've been cutting shows on K-frame, 30 type source shows since December of last year. And the other big thing for this group is we do now have an audio mixer And so some of the things that David mentioned, I think we're beginning to address, and he's kind of got it in a form so he can start to evaluate that, and we're looking forward to, you know, additional feedback there. Just to kind of give, let's see, am I sharing my screen yet? No, I'm not. Okay, hold on. Give you an idea. I'll flash the audio mixer, but before I do that, I think I got a PowerPoint slide I just want to kind of go to
Sure.
real quick, just to overview it. So AMP, there's a SaaS-based orchestration layer you log into. There's a bunch of platform tools that you get that allow you to attach compute nodes, and they can be on premise, they can be in a truck, they can be in AWS, and then on those nodes, you can basically run up applications. And this is a list of, we've got more now. We're just adding replay. But think of, I'm building a control room. What do I need to put together? And there's a notion of being able to routing all those flows within a node are very accessible. And so that's the context. So we've always wanted to, the main target for AMP has always been live production. Figured if we could solve that, that's the hardest technical nut to solve. Mm-hmm. And we did always recognize that it's not the days of Charlie Chaplin. You need sound with the pictures to make compelling content. So we wanted audio mixer. I will say we built something because there was nothing there, and it was, you know, pandemic came and we got to go do something. One of our key strategies is partnerships, and there's people on this call we're excited to see, you know, whether it's intercom, audio mixing, other things that we're envisioning seeing third-party products part of this ecosystem, and there's some exciting things in the very near future there. So without further ado, oops, screen there. So this is the audio mixer that we've built. It can go up to, at this point, it's software, so we could do more. It's a 64 stems, if you will, in banks of 16 just for real estate. Up to 816 outputs. This is you know, a configuration with 16 inputs, eight outputs. We can go bigger. Each channel, you do have the ability to do a pre-fade. You've got gain, pan. You can do EQ. Right now, it's not a waveform based thing. It's you know, you turn on what, you know, high pass, low shuffle, all those kind of things. Compression. Same kind of deal, that you can add that, and then delay. So you mentioned delay. You can dial in the delay on any individual inputs. You can assign these stems to groups, and so, you know, talent mics, music bed, you know, other effects, whatever you want there. To groups, you've got master there, and then you've got independent channels. Again, up to 16, where you can assign that, and then you've got your dynamics and all on the output as well. In addition to subgroups, there's we also support, you know, VCAs. So you've got quite a bit of tools. A couple things to mention. One is, I think, as you guys know, there's some cool things you can do with a mouse. You can hover over. Where's my mouse? There it is. You can hover over a particular scene and just, I'm scrolling right now and do that, or I can click on something and it doesn't do there's no pop. There's kind of a fade that happens there, so I can move things, I can mute things. But again, trying to do a crossfade with a mouse is kind of hard. So we do have support for MIDI panels. The one that people have used the most is the Behringer X Compact, typically assigning the subgroups to the faders with a master. It's got 9 motorized faders, and then you can map whatever, you know, kind of buttons you want to that. So in terms of extending bigger, that's not hard. There's just kind of a UI real estate and what panels that we do. Right now, it's essentially doesn't support 5.1 or Atmos, but you can, on an assignment, one of the cool things about it being it's part of the video chain is every video source. If I click assign on a new input, I get the thumbnails, but any video source I can have. And let's say I brought in audio is through a a COTS server with an object card, 16 channels of SDI. I can bring that up, assign that. I'll assign something so you can do an ident. It's not going to be fairly boring, and it's not even turned on. So, but I can assign, and then I can go in and in this case, if there's only a stereo pair, but if there were 16, I could pick those off. I could say I want left, I want right, I want mono. So you can break that out. You do your breakaways on the other side. And so the feedback with those who've kind of taken this to air is it is a quantum leap in what they can do.
I was going to say, yeah.
Yesterday or last year. So it's getting there. It's not like I'm not, this isn't a huge desk or anything like that. But there's quite a bit you can do, and it's responsive. Because it's notion of video and all the timing that we do and the time stamping, you can the other thing that you can do is you can use this as essentially an AV mux at the output to take your program audio out with your program video, put that together, add what delay in it, and it's been quite effective. And so it's pretty exciting to get to this. There's a great partnership on intercom that's super near to the shoot as well. So integrated comms where intercom audio and program audio can be exchanged, mix minuses set up, that kind of stuff, so that you don't have to deal with intercom as a separate system. You just spin it up like another app in the amp system. And right now, just to kind of show you, this is a demo system. We've got this thing called Hillsboro. That's Hillsboro, Oregon. That's a 1RU server. And then to mark, we're running a G4 in AWS. It's just 2 nodes. And then you can see there's just myriads of applications that we're spinning up as microservices on that. They're all connected. If I go to a routing thing, of course, there's a lot of sources that aren't there, but I can see my sources. I can route them like that on really any of the apps, like the mixer. If I go back there, like I said, you have visibility and assign sources. And so it's pretty clean and pretty powerful. And so I think, we've come a long way in the last year or so.
Well, it's pretty amazing, Mike. And as you say, it's a huge leap forward. And it's interesting too, with the thumbnails and things like that. It's interesting that we talk about just in general replicating the functions that we have, but also inherently being an integrated cloud solution gives you some capabilities that you don't have in terms of things being inter-aware.
Correct.
And I think that's where we're kind of going to get to. It's like, as the solutions that you and others start providing it more sophisticated, then we're going to go like, well, I don't want to go back to having to do it the old way. What you talked about partnerships, and in terms of audio, I mean, you could develop this into a CalRec or a Lavo or an SSL. How do you feel about, you mentioned intercom partnerships. How do you feel about audio partnerships? Is this something you're also encouraging? Do you see?
Yeah, wholeheartedly. You'll see, literally within a month, some of the people on this call talking about what we're doing together in the intercom area. We have, from a mixing standpoint, we're really committed and dedicated. This goes all the way to the CEO and our ownership. Luis Hernandez, Black Dragon, building a partner ecosystem, and so I think getting to the cloud is not just about one company. So we're dedicated to that. We have dedicated resource for SDK development and things like that. And so it's very important for us. So I think that the best thing for the market is that there are manufacturers of current audio consoles that are in there and with their wares, and it's on a connected ecosystem. That's the goal. Not everybody is as close to being able to do things in the cloud as others. So that's where different approaches are required in the interim. But yeah, we're not trying to corner the audio market. But we did but in order to get the other stuff that we're doing more adopted, if you don't have audio, you know, you're just stuck, right? So this is out of necessity, not out of a grand master plan to rule the world in audio.
Well, it's, yeah, listen, you and Ian and everybody else are to be, you know, commended. It's an excellent freshman effort. I mean, it's really, there's a lot of stuff in there, you know.
Yeah, and it helps guys like Ian used to be an A1, right? So it's not like we don't know anything about audio, even though we're known for video. So,
yeah, well, my console design days go back to when we used soldering irons. So, you know. So anyway, well, thank you so much, Mike. That's great, and congratulations, Tim.
Yes, Rob.
I think last spring I called Dave Van Hoy out of the blue and asked him if he was thinking about audio in the cloud, and he answered in the affirmative. And I think shortly after that, he kind of dragged you into it. And you guys have done deployed a lot of production control rooms in the cloud with various audio solutions. And you've been talking to everybody on this call and in the middle of it. And I wonder whether you can kind of fill us in a little bit on where you've been and where you've been headed to.
Certainly can. And I still have a soldering iron, by the way,
Yeah.
even though we no longer need it. Well, we hope we don't need it. So I have a little bit of a slide deck. Well, actually, not so much a slide deck, but pictures, which I'll go to in a minute.
Yeah.
But ASG for the last 15 months or 18 months has been working on what I call a virtual media, or what we call a virtual media platform. And a part of that platform is to put into the cloud real-time virtual production control room. And a number of the people that are also on this call we've worked with on one level or another. In particular, you know, on the audio side and the comm side, there's been, let's just call it test cases or proofs of concept and continued development. And it's interesting to me that I hear kind of like in the earlier part of this call, the difficulties that a number of people have experienced, you know, the Reaper experience and how difficult it is, the vMix experience and how difficult it is. And I would say 15 months ago, we went through exactly the same thing, where we started out with Reaper and it's a DAW thing, and now we've moved on. And we moved on on the audio side by working with companies like Telos, and I don't want to steal Greg's thunder, but he's coming on in a minute, and also with Harrison. And again, I'm not going to steal their thunder because they're going to come on in a minute, but I'll at least talk about kind of what we've done and why. We've also experienced the kind of REMI thing, where there is, part hybrid, part on-site, and then you push it to the cloud or you transport it wherever. The goal at this point, though, is for full cloud production. And if I can share my screen, and I've got, some home pictures that are kind of interesting. So let me try and do that.
Should be able to do that, Tim.
I should be able to if I can find it. Yeah. Share. And then we'll go to full screen here if we can. So this is an opening slide. This is sort of a bit of a production system overview. This is the sort of overall solutions. This is beyond audio. This includes the entire production control room. And it's sort of very, very much simplified. And the point to make here is that the little green box, or the large green box in the middle, is a virtual private cloud. And within that virtual private cloud, we spin up any number of VMs. And the VMs will be for contribution sources, video switching, graphics, teleprompting, so on and so forth, and of course audio. The approach we took was one where security was paramount. So the entire thing, that little red line that goes around the outside of the whole thing, is a VPN. So for the most part, although you do have to push out for content distribution, and there may be some circumstances where the contribution sources are external in the public internet, for the most part, everything is contained and secure within a VPN. Over on the left-hand side, we have our video switcher and also the audio mixer. And this is all fully integrated internally, and we are utilizing NDI as the transport to move signals once they've been brought into the VPC, move signals around, route them, switch them, process them, and so on and so forth. So this is a kind of an overall view of how we view a virtual production control room, and this has been deployed in a number of places, used in live productions with disparate users, a TD in San Francisco, contribution sources from New York, talent in San Diego, and there are no question little different difficulties that you have to get over, and there are things that you have to worry about, but it's proven successful, reliable. Latency's not too much of an issue. I'll go back to something that I think it was the guy from Sky said was that, drift or synchronization is stuff that you have to worry about. But for the most part, if you pay attention, you can get that done. So I'm going to jump down to the next slide. So one of the things that's really been brought home to us is that there are production companies or entities that want to use certain pieces of software because of on-prem or existing experience. So you might want to use graphics from Ross and something else from some other company and switching by AMP and whatever. And this is all based on history, and it's based on your existing workforce, the training that they've had, the experience they've had. On an audio front, it seems to be a little bit more open in terms of audio signals. As long as I've got my fundamentals in place, it's okay. We're not going to be specific about I need this particular console. But what is quite clear about the audio side of it is from an A1's perspective and also from a TD perspective, they definitely need to be separate. So although I appreciate what Mike just showed as part of the AMP system, there's certainly a clear delineation in terms of audio roles being separate from TD roles. A TD does not really want to be responsible for the audio. And part of what we did was make sure that all our audio contribution sources, even audio coming out of a graphics system, is routed into an audio mixer and is given control, or is controlled, managed, balanced, and then ultimately remuxed back in. So it's controlled by an A1. Most of our recent experience has been working with Harrison on a product called VBM, and I'll just allude to that a little bit. And then also with Telos, which has IQS as they're both cloud-based engines. I would call them small format consoles. They've got stereo busing, multiple stereo buses. There's a limit in inputs, and the limit in inputs in many cases is driven really by screen real estate and what's practical to control. I think actually the Harrison VBM, there is no actual limit. It's just when you run out of processing power or when you run out of screen real estate, and you could actually manage it. The nice part about these systems is that they've come from broadcasters in the broadest sense of the word, and they understand what a TV mixer needs to do. The mix minuses are, to all intents and purposes, automatic. The integration with communication systems and IFB has been thought through to the point where it actually works. And in that case, we've utilized Unity and then Infinity VIP. And Martin is also on the call, so I'm sure he'll talk to the Infinity piece. Something which is perhaps, kind of envisioned in the simplistic term, or a simplistic way, is deploying this thing. It's a very nice concept to be able to sort of spin this up and then spin it down again when you don't need it. And we have done that in both the Google Cloud and in AWS. In practice, the systems, somewhat like on-prem, need to be a bit more stable than that. there's certainly work process where there's standard operating procedures that you have to go through, because now which are different from on-prem when everyone is remote. So if you have your teleprompter operator in Los Angeles and the camera guys are in New York, there has to be, or the talent's in New York, there has to be a different operating procedure. And sometimes it seems to me at the moment to be a little bit longer, or you have to understand what's involved and how you test this thing through pre-going live or going on air. So it's interesting in terms of we think about consumption and spinning up and spinning down. It really is, at this point anyway, takes a bit more time to get that sorted out. But once it's sorted and you've gone through that pre-show check, then generally speaking, it's ready to go and goes. So with that, I'll leave it. I know that Gary from Harrison is going to talk about scanning up and scanning out. Thus far, our experience has all been with stereo busing. There's a lot of conversation about surround sound 5.1 and then out to Atmos. That requires larger consoles, different control surfaces in some sense. And up until now, the control surfaces we've been using have been general purpose, Icon, X-Touch, the MIDI based or Mackie Huey based protocols. However, so I'll let Gary talk a little bit when he comes on later about how this scales up and out. Yeah. And then lastly, just for the pictures, this is a typical one of our TD stations, new office at home, the same for audio. This is now in a home-based environment. There's a quick shot of a MixBus BBM screen. It's similar in many ways to a console that you'll see, but it's dedicated for broadcast. It's laid out in a way that is practical and is understood by broadcast mixers. And then here's another one, which is part of our Telos engagement and experiment. There's a physical surface on the right-hand side, which is a Telos surface. And there's a Telos screen, which is controlled by those faders. So having said that,
great.
I will stop the share and go back and
great. We'll come back to some discussion when we get through this. But thanks, Tim. It's just interesting how how much this has moved in the last year. I mean, we were just nowhere with any of this. But
hey, Roger and Tim, if I might just interject, because Tim, you mentioned just kind of said, unlike Mike, we see TD and A1 needed a separate interface. And if I misspoke, I just want to clarify. So we see the same thing. Sure. People typically use a dedicated K-frame and a dedicated audio mixer. The fact that the audio mixer you can see pictures and video flows is just a nicety that helps the production. It's not that you're trying to cut the video on that device.
Yeah, if I misspoke, sorry, Mike. No, it's really treating them as separate disciplines. And even though there may be other vision mixers that have audio built in, generally speaking, the TD kind of, unless it's a small show, doesn't want to manage it.
Yeah.
As you just
agreed.
Well, this goes back to master control. In master control, we're trying to get rid of, or commercial integration, we're trying to get rid of operators. So we're combining functions, but now we get back to production and these functions don't combine even in the simplest show. Anyway, Greg, distributed mixers, you guys have been doing this aspects of this in radio for a long time. You've had mixers running in data centers, the BBC regions radio, lots of national radio networks here in the States, distributed DSP. You've had parts of this for a while, but IQS is sort of your first designed to run in VM on-prem VMs, and being stretched to its limit or beyond what you originally intended it for by Tim and other people. But you want to fill us in a little bit on what you've been working on?
Sure. Thank you, Roger. And I will do the sharing screen. here, 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 and there. Okay. So everybody see that? I don't want this to be just a product, sales type pitch. So understand that, we've talked a lot about theory, and I believe it'll be very valuable to focus on a concrete example. So this is a product, our IQS. This is how we market it. And we are finding the various aspects of this that are important to people. So as been mentioned, people tried to use digital audio workstation kind of software, because that's what they had. To be clear, this is a real broadcast audio mixer. It's from its origin, our products have always been based on audio over IP, and the IQS is AES 67 audio IP in and out. It's what we did is we took our mid-range kind of single facility, single studio mixer and brought that out. We talk about it, we bring the software out of the box into a virtual machine and then able to deploy it on a server. So it has all of the features that our Axia mixing consoles have had, very broadcast friendly, has been mentioned, completely automatic mix minuses, all of the logic for your control and contact closures, 4 program buses. You got your phone record. You've got a whole monitor section there in the logic. You've got full channel processing on all channels. EQ dynamics, the ATS are. So this is what it looks like. Thank you, Tim, for showing that folks are using this. We're doing things like, at first glance, those orange bars are the fader knobs, and we figured out that when you bring this up on a touchscreen, you don't want to be hunting with your finger on a little graphic that looks like a fader knob. Why not give them a bigger target area? So our UI guys determined, hey, let the user grab anywhere in that column, anywhere in the orange column or above it, and use that as your target. So when you start to go to touchscreens, you are using the intuition from the mechanical device, but you want to be able to use a little bit more of your intuition. So it's really important, and this is the first thing I'm hoping to talk about, not just the product, but our methods and our approach to using this new technology. So what you really want to do is take advantage of what can the new technology do. So this is not, the IQS is not just a software application that you install on your computer, your Windows machine, or whatever. This is specifically server-based. When you get at it, you use any browser. So it's fully HTML5 GUI using your browser. You are not installing anything on the user's machine. So if you needed another person to jump in and in the middle of the show, all they have to do is log in to that page and they're on. Works with a touchscreen, as I mentioned, which you want to think about the ergonomics of touchscreens. One of the cool things you get, and we can't take credit for this, but HTML gives you multiple simultaneous users. So everybody sees what everybody else is doing. And in a pinch, you can even run it off of your cell phone. That screen that I showed is just the basic screen. We have a custom screen builder. A lot of times you don't want people involved to see all of the faders. You want to give them a scaled down view of what you're doing and fewer buttons and knobs. This is one of the things we've learned from radio. Next generation radio is often described as, they're the presenter. Give them just the controls they need to get their job done, not a million knobs. So as an example, this is just a view of the bottom one actually is running on AWS. The top two are running on a multi-core server in our R&D lab. When we talk about cloud, remember that cloud just means who owns the machine. The real underpinnings here are going to virtualized server software. which means you now can control your on-air, staying on air and reliability and using standards. We've always been about using standards. So what are some of the standards that we're taking advantage of here? And the main one I want to touch on, just very briefly, I'm not going to go too deep into this, but to be aware of it. When you start deploying software on servers, you want to do it the same way that the IT industry does. And so this product is deployed as a Docker container for a Linux server. Now that means it's a container that you can fire up and run as many as you need to. You can put it in a VM if you want to, but you don't have to. You can run it on premises, or you don't have to. You can run it in the cloud. And we run it on AWS and Google, as many instances as you want. And then we license it in terms of how many faders. So a lot of people find this, they like the idea that you only pay for what you need to use for as long as you need to use it. And the real point about Docker is, if everybody knows, we're in the broadcast business. We need to stay on the air. And you do that by getting redundancy with containerized products. Because in the sense of your staying on air, the redundancy means keeping the product function running. There is a whole IT industry ecosystem out there running this way. This is how the world works. This is how all, Amazon store and Google and all that, using containers, there's software, orchestration software that keeps these things up and on demand. So basically, it performs this function that, we've done for years. I've told this story that I believe the IT industry learned from the broadcast industry, how to stay up, how to stay on air. So now this turns around and we use these tools so that, if the server stops, if you have a hardware problem, the Kubernetes management software starts what you want running on another server. This whole design of containers is the IT industry's way of doing that in a reliable, quick, and as easy as possible way. So again, we say cloud, but the real value is taking advantage of these high reliability for the lowest economic costs out of virtualized software. And the goal and the promise is, and the achievable is a system that detects and recovers from failures before you even know about it. And the point is, there's this question, can we trust the cloud for our broadcast functions to be, the show on the air? And the point is, the more mission critical the function is, the more that you need these reliability methods. So following the way the world gets this done, we can use it too. And that's about it.
Yeah, that's a really great point, is that I think when we try to make virtualized systems, when we try to make them redundant, we do it in the same way that we do it in broadcast. And your point is, we need to look at how the computer industry manages this, and some of that, high availability is built in to how VMs work in general. Mm-hmm. The bank doesn't lose your bank balance, amazingly, usually. Well, Greg, that's awesome. What is it, you kind of started at one point with the IQS. You've been thinking a little bit about some other things, and this is sort of traction in television. And I remember sending you an email last spring saying, have you ever thought about running these things in the cloud and then or in virtual environments? What are you kind of thinking about going forward, or what's on your kind of scratching your head about?
Yeah, so we're in the mode of, obviously this is new territory for everybody. You can't go off and do your research and come up with the best answer. You really have to listen. So this is one of those dynamic times where you have to listen and react and iterate for which interfaces are important to people. We did all this virtualization of the function, and then we hear how important it is to people to have the physical, still have the physical faders, have the physical stuff there. And that's where a lot of the difficulty and the cost is, so we've had some customers flat out say they are going to tell their people they're not going to get physical faders. They better get used to the touchscreen. So even at that level, there's change happening, and the different interfaces. I'd like to put a plug in for when we created on the committee for AES67. We included the AES67 SIP unicast mode for the reason for long distance WAN connections. And in this case, right now today, as everybody's well aware, support for multicast, in the cloud is rather limited, if at all. So you can use the SIP mode. And it's something that unfortunately SMPTE 2110 didn't include. But there are other coming out of industry, other solutions as well, which are unicast based, which will work in the cloud. So, you have to be flexible and adapt. We're paying very close attention, to what the solutions are possible.
Hmm. Well, and you guys you guys essentially invented IP audio, and were very instrumental in creating AES67. And in terms of your radio applications, those sort of wide area network things have always been part of the landscape for your deployments.
Sure. I mean, the story is, of course, we made the Zephyr, decades ago, and we knew someday when the bandwidth of the WAN, was there, you wouldn't need codecs anymore. So we're going to be out of business. So we figured we better put ourselves out of business, not somebody else.
There you go. Well, that's great. That's fantastic. I think, Gary, we're going to jump to you in Nash Vegas there. You kind of got a call out of the blue from Dave Van Hoy, I guess, probably. Last summer sometime, or last fall.
Yeah, it was late last summer. Tim called me and asked if we were interested in maybe getting back into this broadcast game a little bit. And we have some interesting technology that we've been working on for a long time. And it's really applicable right now. So I'd like to share a little bit with you.
That'd be great.
Pop my screen up here a little bit, if I can.
Yeah, some of this is interesting. It's old hat. Some of this was old hat for you.
I wouldn't say old hat, but we've been into this for a long time. Can you see? Can everybody see the screen up here?
Yep.
Okay, that's just a little montage of it, Harrison. We've been around.
There's a little film console, 3-operator film console.
Here's a tiny format console. We specialize in really, really large mixing systems, and primarily VM-based DSP mixing systems. And these are just a couple of examples. Here's a nice rack full of DSP processing. A couple of different control surfaces that we make. These are all real big, build-to-order, custom-made, large format console systems. And then we have hundreds of software products that we have pulled out from that DSP technology that we've been developing for well over the last 25 years. So it's been a long go for us. Specifically for virtual broadcast mixing solutions, Tim already brought up the VBM system that we've been working on for the last year. This is kind of a smaller format thing based on we make a couple of different DAWs, and we base this system off of that, made a dedicated broadcast mixer for that. And it's smaller scale. It'll scale 8 to maybe 32 channels. And it's got a really nice dedicated mix minus matrix on there. Good comms, lots of channel plug-in processing. It's a mono stereo type system. And we've deployed that with ASG in various locations and kind of went through the proof of concept thing. And it's working really well. It's actually going fast and working really, really well. But to scale up, I'm sorry, Roger.
There's some nice, you're talking about comms, you have some nice features there. You have a closed fader chat feature and some things.
Yeah, some chat room features, lobby, automatic communications when mix minuses are automatically created, independent level controls, and muting, all that kind of stuff we've integrated in it. Broadcast consoles haven't been our main business over the last 10 years or 15 years, but we have a long history and we've done a lot of work there. So we understand the jargon and the lingo and how things need to work. So it was actually a pretty easy transition for us. When we're talking about scaling up, we have a whole different technology that we've been deploying for well over 10 years, which is a large format console system we call Tryon. It's made up of 3 really core pieces, the what we call an X engine, and this is a virtual machine-based DSP processing system, and we're actually on our 3rd generation of that. So this is something we've been doing for about 12 years now. We have a system we call ICUS, and this is a real-time metadata control platform. So this is a software control for this entire system, and I have a nice block diagram. We'll see how that all goes together. And then, of course, we make console surfaces, and they can be, you know, relatively small, maybe a 16 fader thing, up to something huge. And you saw that picture at the beginning. That's a 160 fader console. I'll flip back there and show that to you. So it's 160 faders on here with 3 people driving the physical console, 2 or 3 people in the machine room, and people all over the place. So it's a fully remote control, multi-operator system. The processing is scalable, highly scalable. We can take this well up over 500 channels, and we have systems deployed all over the world that are that size and bigger. Multi-operator control. This is something we started doing back in the 90s, where we were doing these big post-production systems, and a guy in the machine room needed to have access to everything to be able to control the entire system without having to go into the mixing room. And so we've been doing remote control audio for many, many years. All the formats. This is a wide busing structure system, mono, stereo, 5.1, 7.1, every 0.1 up to a 16 wide format. We've got the full Atmos object routing and panning interface there. It's already built in. Did that within months after Dolby came out with the Atmos format. It was necessary for our customers to have that. Monitoring, same thing, Atmos, the 7.1.4, 9.1.4, and up to a full 64 wide monitor matrix on here where we can feed 64 speakers. And believe it or not, there's many re-recording theaters that do that, and it's pretty impressive. We have some interesting things built in that come along for the ride. We have a really nice mix-minus IFB matrix built into the system, so you can talk back directly to it. Multi-studio monitor feeds with mute logic, tally logic, all that broadcast-centric stuff. And we make hundreds of specialized processing tools for voice, sound effects, music, instrumentation stuff. So we're doing a wide range of signal processing, and a really nice broadcast metering package in this system. I'm going to move on here. This is a very simple block diagram of the VBM system that Tim was talking about. So this is a GUI-based mixing system. We can drive that on a single GUI, or we can do a split screen GUI. And then we have an alliance with a company in Hong Kong called Icon, and they make these really nice controllers. So they have this base controller, and then you can add 8 fader blocks on there to kind of scale this system up. This we would call a smaller format mixing system. This is what we started out with, and where we've done all of the proof of concept stuff so far with ASG. This block diagram is of our large format system. So what you see here in the red is everything that we deploy in a virtual private cloud. So the control, the ICUS control, the metadata control platform, that would run in the cloud. And then we would spin up any number of virtual machines to do the DSP processing for a console or multiple consoles that could talk to each other. What I show here is just a single, representing a single DSP system, or maybe we spin up a virtual machine to do channels 1 through 64, maybe another one to do channels 65 through 128 up to 192. We might do a separate one for monitoring, mix-minus matrixing, master channels, talkbacks, all those kind of things, kind of the support VM. And then of course we can scale that up however big it needs to be. You know, we can get well over 500 channels. We can, you know, the audio ins and outs are in the thousands range. Roger, you mentioned paths. There's thousands of them. You can,
Yeah,
the routing is completely scalable.
Yeah.
What you see over here is I've represented kind of the whole point of this is all the remote control. So I'm showing an A1 audio control room. This has complete control of the entire virtual machine channel, full processing channels, IFB matrices, all the monitoring stuff, snapshot, metering, routing, all those kind of things being controlled, and a large format console. Those can be custom made. We can make those as big or as small as necessary. And then what I'm showing here is just as an example, maybe 3 separate remote control locations, maybe an audio assistant, maybe they're in the A1 with the operator, or maybe in a separate room by themselves. They would have complete control again of everything in the system. You might have a standalone system that is a complete audio backup. It can access anything on the system. If anything goes wrong anywhere, it might be nice to have a system sitting there ready to go. And maybe another full control system in an audio engineering office or in a machine room or wherever that might be. It just indicates that all of these are on this, what we call an ICUS network, and it's all real-time control of the entire system, and it can scale up, and it can scale up big.
So what you're, just to cut you short here, Gary, what you're talking about is that this technology or these systems that you deploy on the film lots, all of this is sort of translatable to the cloud application.
Yeah, absolutely. You know, that VM based technology, we call it VM based technology we're running on. These are virtual private clouds on location. We have these all over the world. I mean, whether it's one big one or multiple small ones. Somebody said, you know, it doesn't matter where the hardware is or who owns it.
Well, you made a decision, and we got to move on, but you made a decision when you started making these. You know, you don't sell a whole lot of film consoles at one time.
No,
so you made a decision of like, we're going to have Dell or HP build the DSP. And
yeah, that was a conscious decision about 15 years ago. You know, we were trying to figure out, we had done digital consoles before with proprietary hardware, and we just didn't want to do that anymore. And it was very expensive. By the time you bring something to market, it's obsolete. It was just on and on and on. So, you know, a lot of manufacturers went off in the FPGA direction and proprietary hardware and these kind of things. We totally went in a different direction.
The other way.
And we said, okay, AMD, what can we do on your server grade motherboards? How much DSP can we actually run on here? And we went through that whole process, and we now, you know, this was quite some time ago, but we started scaling these things up, and we can build a very large system, and we have these all over the world. They're not, you know, the quantity is not huge. This is not a huge, it's kind of a niche market, but the technology is very interesting. And the guys on these big post-production lots, they really like that technology, not because of the technology, but it did save them some money by us not having to develop and build and sell them proprietary hardware. It was a lot less expensive for them to buy these big consoles. They're very expensive to begin with, and anywhere we could cut some of the costs out of it was very advantageous. So that decision was actually pretty easy to make. It was hard to execute, but we did. And here we are, you know, 12 years later, talking to this group of people, and we have some very interesting potential solutions here. And a lot of it is directly applicable. A huge amount of it is directly applicable.
Well,
so,
we'll be interested to have
to
some of those
here.
Conversations and hear a little bit more about what your roadmap is.
Yeah, thank you.
Great. Thank you so much, Gary. That's great. That's fantastic. You can stop sharing your screen.
And I just can't figure out how to do that. I cannot. Can somebody stop?
It's the green thing at the top.
Yeah.
Okay.
For some reason, it just goes away when I do that. Thank you.
There you go. Ewan, it's getting late in Holland there. Thanks.
Greetings everyone from Holland. Yes, we're still awake. No worries.
Yeah, Anthony was giving a pretty good plug earlier for your auto mixer there.
I think I'll just shut up and just let you know. Just you know, that was an absolute wonderful.
You owe him a beer, at least. I think. There you go.
I think we owe him more than one beer. Yeah, absolutely, over the years. But I mean, Eurosports has been an absolute phenomenal development partner with us, and you know, you've seen the results that they've had, the numbers that they're talking about there. I mean, you know, when the Olympics, or should I say, when the Olympics happen, you know, to be able to mix the kind of numbers that they're talking about with our auto mix solution is absolutely phenomenal. And, you know, it's an Olympic standard. So we are absolutely honored to have them as a development partner. But I guess the challenge is probably not a lot of people know who in the hell Llama is, because we are a sort of unknown little secret, this tiny little Dutch company that's established 2 years ago. So maybe it's a quick, good idea to briefly introduce the company. So Llama stands for Lean and Mean Audio. So, you know, the whole idea of the company, it's a software development company for broadcast audio solutions. That's our focus. And currently we have two main solutions. One of those we've already talked about, which is the Llama Auto Mix solution. But the other one that is also potentially of interest as well, Roger, is the Auto Sync solution as well. You were talking about synchronization, and you're talking about the differences between latency and synchronization. And our Auto Sync solution actually, in real time, compares the delay between different audio signals and effectively provides in real time, down to one sample, synchronization for those signals. So, our friends at Eurosports are also going to be using us for the auto sync for the Olympics as well.
Oh, wow.
Yeah. Awesome. So, so very brief introduction. I've not got a presentation because I was told not to. I'm very, very good for not listening to you, Roger. But ask your questions. Ask your questions.
Well, you know, I think the question is a little bit, you know, I think we talked about what you're doing now, but what kind of, we see this sort of expanding what people are doing in VMs and in the cloud, and kind of what's your, you know, how do you see that? How do you see the input of AI, the influence of AI?
Yeah.
What's the kind of, where do you see the kind of what people are doing in clouds and VMs? How do you see that expanding in audio?
Well, it's been such an interesting time, hasn't it, with COVID, that it's forced people into research and into actually developing things that they would not normally do, or it would be incredibly slow to develop in real time in normal circumstances. And I think from our side, because we're coming from, you know, we are a relatively young company, we're coming from a software background. We have no historic baggage with regards to bastardizing existing business. So we're really looking at, you know, how do our development partners, how do our clients want to use software technology for manipulating audio, and be that on premise, be that in virtual machines in private clouds, or be it in the cloud. We want to be completely agnostic and be able to offer those tools that really fit within the client's workflows, because I think that's the key thing as well. We're not forcing, it's not the tail wagging the dog. You know, it should really be, how are you guys working today, and how can we adapt our solutions to really fit within that workflow? And I think, you know, what also Tom was saying as well, you know, Pandora's box has been opened. It's not going to be closed again. You know, I think everyone realizes that, you know, from a technical perspective, absolutely, but also from the business perspective. Let's talk about the business here, because the business is really got a requirement now to do even more, what we were talking about with Tom as well, to do more, to do it less, to be more flexible, to be more scalable. And I think that's where, you know, the ability of software-based audio solutions really plays. So I think this is really just the start of a really interesting and really exciting time. You know, at the moment, a lot of people have been piecing together all these different elements that weren't really necessarily designed to be working together. You know, the idea of using Reaper, you know, incredibly imaginative, wonderful ways of doing things, but it's not been designed from the beginning really looking at the workflows and how to do that. So that's really what we see as the opportunity, and that's what we really see as our focus, working with our development partners to do that.
Yeah. Well, fantastic. Well, it'll be interesting to see where kind of where you go with this. And one of the things that, David and I were talking about a lot the other day too, is things like the auto mix capability are going to be things that people are going to want to see built into solutions that as we get more and more production, we get less experienced operators. People don't want to have to be scientists. They want to be able to hit the make it sound better button.
Well, I think it's also, a question about focusing on the real value that the operators can give. If there are things that you can automate, and, this is also where you were talking about AI as well. One of our founding members of the company has a PhD in AI. So, we're absolutely looking at the opportunities there. But the question is, what can you do through smart solutions? And then getting the operators to be able to concentrate on what they do best and, concentrate on the bigger picture. But ultimately, you're going to be able to do more for less in a more flexible way. And that really is what it comes down to.
Well, great. Well,
Pandora's box is open, gents.
Okay, well, we'll look forward to it. Let's see. Martin, are you there?
Hello.
Yeah, you've been, we've covered your stuff. I mean, Mike talked about it. Tim talked about it. I don't know. What do we need to say? I don't want to hear a demo of it. I've had the demo 3 times.
Yeah, I mean, I do have some slides for those people who haven't seen it before, but and I could also do a demo, but you don't want to see a demo, so.
Well, we can schedule a demo, but
I can throw some slides up and talk about what we've been doing.
Give us a couple of slides. I want to hear what you're going to do about a booth kit, though. I think that the booth kit sounds like it needs to be on your list.
Yeah, probably. Right. Okay. So that's the wrong one. What have I put up? No, I put up the right one. What does it say on the screen?
Okay. Starting the stopwatch.
Yeah. Okay. Sorry. So as long as you're seeing a slide that says VIP Virtual Intercom Platform as a big splash screen, then you're watching the right one. Okay. So thanks, Roger. I just had about 3 PowerPoints open at the same time. So yeah, as a few people alluded to, this what happened in March 2020. The pandemic hit, and this is what my calendar looked like. So the last thing I did was flew back from San Francisco to London Heathrow, and then pretty much straight after that, within a few weeks, people who knew the Infinity system, which is a hardware-based intercom system with no central matrix, where everything works around a distributed platform of connectivity between the panels on a network, started asking the question, do you have anything virtual that can replicate what your hardware does? And we didn't. But we were in a position where we were lucky enough to have done some virtualization work during the development process of the hardware product, and we were able to restart that work. We had to virtualize it to start with, because when we were designing the concept of this intercom system, we didn't have any boards to play with, and so we fudged it with virtualization, and then virtualization became VIP once we breathed some life back into that latent project. So what is VIP? Well, VIP is, Greg talked about this earlier when talking about the IQS console. So it's using the same technology of containerization to run an intercom platform on a machine using multiple containers. So a VIP system comprises of 1 Docker container per panel running on the same server. And the benefit of doing that is it means we can build an entire intercom system on the same server using multiple Docker containers. And a customer who wants to scale up or scale down can just fire up more containers and have more intercom panels. And it means that we can maintain the same AS67 multicast structure in the server that we do with the hardware panels when they're connected to a local area network. And we can use the same distributed architecture that we use in the hardware system. So we were able to sort of rather glibly, and the software guys hate me saying this, was suck the software out the top of the hardware panel, containerizer it, and then run it on a server, and that's sort of what it is. But an intercom system is nothing without 4 wires. You still have to connect to the rest of the system, and of course, as we've discussed in this when we've looked at virtual consoles, and we've talked with some of the people that we've been working with on proof of concepts here in this discussion already. Connectivity inside the cloud and also on-prem super important. So Infinity has a virtualized version of the link codec, which is our, which in the hardware solution is our connection to the internet using Opus. But we virtualized it so we can do interconnectivity in the cloud on Opus. We can now do AS67 unicast, which Greg mentioned before. We can do AS67 linear 24-bit PCM. And in the not too distant future, we'll be able to do NDI as well, which is something that has really come to the fore with our work with Tim and the team at ASG. So, you know, that we recognize the importance of that. If somebody wants an intercom panel, then we use the VIP server to send them an invitation, and they get a secure WebRTC Opus Audio encrypted panel connection via an email, which then allows them to open up a connection and start using an intercom panel that has all the features you would expect of an intercom system. You know, supporting unlimited IFBs, party lines, groups, etc. Most of the work that we've done has been about cloud deployment, but equally many people are more interested in running comms on-prem, and there are some benefits of doing that because it gives you native connectivity to your audio subsystems. And as I said before, many of the people on this call are people that we've been working with on proof of concepts and things like that. And some of the challenges with cloud deployment can be got around using on-prem. And so there's different horses for different courses, really. But using an intercom panel, much like using a console, clicking with a mouse and stuff like that, using a touch screen, well, intercom is something that people do. They do it all the time, but they use muscle memory to reach for the button. Usually the one in the top left-hand corner of an intercom panel is the one that gets broken first, because that's the one they can find easiest, and that's the one they hit all the time to, you know, to talk to the production crew or talk to whatever the party line is that they're using. So we've integrated the Stream Deck LCD controller, which I know is used in many other applications in broadcast. So we've integrated that. So when used with an Infinity system, you can use that as a hardware intercom controller. So that's looking under the hood. This diagram looks under the hood at what the system is, and on the left-hand side of a server, in this simplified form, you see the components that are containerized. So the VIP server includes the dashboard, which is the control and configuration software, the invitation server and the beacon server, which is the security aspect of ensuring your WebRTC connection is made and secure, and that your panel is connected, and that your audio is using Opus variable bitrate is good. Link gateway is our 4-wire connectivity, and VIP server supports a link gateway 16. So we always kind of give you 16 4-wires to start with as a get your intercom system working, and then however many VIP panels you might need, of whatever size and they might be in terms of the number of keys, rather like buying a hardware panel, and then add any additional 4 wires as an add-on by firing up more containers. And then on the right-hand side is all the back-end stuff that's taken the most time actually in development to work out. A licensing platform, so that customers who want to do an outright buy can do that. A code meter, so that customers that want to use software as a service because they want to fire up the intercom and pay for it as they use it, rather than do a capital expenditure. You know, all of those things in there are what makes it work and makes it different, but also makes it fit into many of the different use cases. So that's a quick look under the hood. a picture of some panels and Elgato. But what I wanted to show is just a couple of the use cases before I finish that have been really important, and they vary a lot. But one of the ones that's come up as customers have been, broadcasters have been looking at using cloud to do real stuff. You know, Alex talked about the work that they're doing at Sky, and these are the kind of things that we hear. You know, a hybrid where somebody already has an existing third-party matrix intercom system, but they want to utilize cloud audio and cloud comms to make it easier to deploy at a venue while still maintaining social distancing by having operators at home. And this diagram shows that, where using a cloud deployment that's connected using our link compressed Opus codec to HQ, picking up audio and comms feeds from the existing subsystems can then be married with comms at the venue, so that operators at the venue can have a mixture of the native comms if that's what they're using, but also virtual communications, or use Infinity hardware, and still have people who are members of the crew working at home or working from their hotel room, or, you know, working from whatever that location might be. So this is an important model because this is one that comes up all the time. You know, we're not naive enough to think everybody's going to rip out their comm system and put in Infinity when they've already spent thousands, hundreds of thousands of dollars on somebody else's system. We're building a system that can build on top of that, but give the flexibility of using a virtual intercom that's scalable and easily deployable. So that's one of the key use cases. And another one which surprised us actually is a model where the broadcaster that we're talking to is not necessarily making any content, but they're bringing in feeds from other places, and they're rebranding it and sending it on its way. And one of the challenges there is that you're bringing in comms from different vendors, and that can be quite challenging. And what we found is that people are interested in using Infinity in the cloud as a means to knit together different comms feeds from different locations, use VIP's capabilities to create party lines and IFBs and stuff like that, and to be able to knit together the different locations. So this is a use case that we hadn't anticipated, but it's one that's come up time and time again, and it's quite an interesting one. So very quickly, I've got two other use cases that sort of fill in the four versions, I guess, and this is using VIP as an add-on to third-party cloud production systems, and the potential of doing something like that, where VIP can exist on a cloud server with, you know, another brand of production services, and some of them been mentioned here, so that VIP is integrated using Link as a means to connect to a cloud console or a cloud router, or whatever those services might be, or a commentary system, of course, and then feeding those virtual panel operators, those people on the ground working from their homes or their loft space or whatever, and then still hooked into headquarters where some of those services are still operating. And then the final application is a sort of pure on-prem version of the one I just showed, where a local Infinity VIP server, either on something that we provided or on another bare metal server, is providing the virtualized intercom and the scalability and the flexibility and agility, whilst also being able to connect to third-party systems, either natively using audio over IP or using compressed audio through the WAN or VPN into the cloud.
Great. Wow. Fantastic.
So we got through a lot there.
Fantastic. Wow. You crammed everything you could in there.
Yeah.
Sign up for a demo. Martin, thank you very much. And I understand you're going to have some news about some partner relationships coming up.
Yeah, that'd be good.
That's great. I think we're going to run a few minutes over, but we'll try to keep going. and appreciate everybody hanging with us. I think this is a hardcore group here. Rob, how are you?
Hey, good, thank you. Yes, thanks for sticking around, everyone.
Yeah. What are you thinking about?
What am I thinking about? How to make an introduction. So I'm from South to Sound, UK startup, and we are AI specialists. So our background's actually from an academic, come out of the university in northwest of England. And so for me, looking at the cloud stuff, we've historically done automated mixing based on premises. So taking the in-stadium microphones and creating an automated and enhanced mix based on that. And in the last year or two, we've really pressed hard to migrate to the cloud. And for me, the thing which gets me out of bed, the thing that I'm pumped by really is not maintaining the status quo, it's what are the opportunities. And for me, having all these feeds coming into an edge server or a cloud server and having that GPU compute ability actually massively opens up what can be done in terms of AI. And we're working with the DCMS funded project at the moment over here in the UK. And we're specifically looking at edge technology and what can be further enabled through 5G. And, you know, if you can get feeds up to the edge or up to the cloud super quick and obviously get them back, what are the opportunities that can be done? So we're looking at AR and VR type applications and sort of what are the wouldn't it be cool if ... That's kind of like our company strapline. Things can we do? And so we still do all of the automated mixing. So it's an AI driven solution that listens to the audio feeds, classifies what they are, and then makes production decisions based on the content that it hears. So in the football context, if it's listening out for sort of the kicks, the whistles, the grunts, the crossbar hits, that sort of thing, it will add those sounds into the mix automatically and then create a really compelling mix. And we also do a sort of gamification version as well, where we actually trigger the samples that match what we've heard on the field. So even those sounds that are kind of right in the center of the field that actually can't totally hear, but they are there in the microphone. So our AI picks that out, and then we trigger some pre-produced content, which is kind of neat for sort of gamification stuff. But back to the cloud, obviously all that sits in the cloud as well as could be deployed on-prem. I'm super interested in the work that we're doing at the moment which is basically treating the audio feeds as data sources rather than as audio feeds that can be sent around, and actually using AI to do data mining essentially. So by that, I mean kind of metadata extraction, getting a semantic understanding of what's actually going on the field of play, or how the crowd are responding at any moment in time. So for me, when I look at the cloud, I mean, actually I see sort of two major things that get me excited. One is the kind of the AI driven opportunities of speech to text, like automatic feed recognition, being able to kind of pull out the metadata and the crowd analytics, that sort of thing, as well as obviously our sort of bread and butter automated mixing around that. So I see that as a major deal. And the second thing I think is really cool is the ability to create personalization and personalized content, whether it's for different geographics or whether it's for different individuals, kind of being able to communicate with that server or edge server. And so right under the hood of everything that we do, we're really based on an object-based audio paradigm, always have been, even before people started sort of talking about it, because that we saw early on that that's the future, having those different audio assets. So everything under the hood of our Mixair tech is based on objects and beds. I mean, some people refer to a crowd bed as an object, but fundamentally we have sort of crowd objects, comms objects, commentary objects, and pitch effects objects. And it's about kind of manipulating those altering the mix with different flavors, like maybe you wanted an away crowd and a home crowd mix, or with different auxiliary feeds in their audio description, commentaries, and things like that. And then creating a personalized mix that can be thrown out to your audience. So for the 5G Edge XR project, that's specifically looking at volumetric video. We're working with BT on that to create a customized experience. So if you're looking at a volumetric video, or it equally works for 360 video, where you're looking at something specific, then obviously the audio's got to match that. Nobody wants to be looking in one direction and hearing the audio sources from somewhere that they shouldn't be. And so we're using the object-based paradigm, being able to, like I say, with the metadata, we pick out the location of the objects as well, so that they can be panned around. So the 360 video example, you're giving viewers the ability to look anywhere they like. And so the audio should match the view that they're looking at. So broadcasting that in an object-based, or I guess ambisonics-based, so that the rotations can be picked up. The rotations of the user on their app, on their headset, can be picked up, and then we deliver them the audio mix. So I think those are my sort of two, wouldn't it be cool if, future-facing sort of side of things when it comes to cloud audio.
Yeah, well, you guys have done a lot of work sort of on tailoring to the fan experience too, that the idea, I think that personalization, will see more of this, of I'm a whatever Manchester fan, I want to have the Manchester
Good man.
This experience or whatever, that you've done a lot of work around that, and I think we kind of see this as we move to a direct to consumer model. Then we're going to see this proliferation, and Tom Sahara has talked about this, of just more different kinds of feeds for a slightly different audience, just in the same way that Eurosport deals with different languages. But
sure. It's a really good point. I mean, I like that you use Manchester as an example, because we're working with Manchester City on this as we speak, for a fan experience mix, so that they're over their OTT platform, viewers can choose whether they want to kind of sit in the south stand with people swearing and whatever behind them, or whether they want to, be in the family stand, or have this sort of more, I guess, vanilla broadcast experience. And so being able to provide those more visceral experiences, obviously it's not what everybody wants, but people do want to be able to choose. And I think once you're starting to get to the point where you want to go, oh, let's get loads of different flavors, that's a nightmare for an A1. But to then use a bit of automation in that space, I think that's where automation sits really well. So that's where our AI mixing is super helpful, because we can say, different crowd beds, different commentaries, you put it in, and then we can create mixed flavors that best suit the audience, and different platforms as well. You need to be aware of the different normalization and loudness constraints of, say, YouTube, or whether it's OTT platforms or broadcast. And so being able to manage that side of things as well, so that everybody is compliant to the regs. As you're pushing out more and more audio mixes, like the Llama Eurosport thing, it requires automation. You need to be able to.
Without it.
Yeah.
Well, great. Well, thanks, Rob. We'll be interested to hear your progress reports. So.
Yeah, they'll be forthcoming.
Okay. Hey, Tom Knowles. How's it going, man?
I'm good. How you doing?
Are you still awake?
I am, yeah. I kind of feel like I'm going to be last speech at a wedding where half my jokes are taken anyway. So.
Oh yeah, well, I figured that would happen.
Unfortunately, we're not all drunk, so that's the
that's the only problem. Tom, what have you been thinking about?
I mean,
you also made this. SSL also made the same turn that Harrison made, where everyone else went to FPGAs off of programmable DSP.
Yeah.
SSL went to general purpose processors.
Yeah, so we went to CPU x86 Intel based
supervisor computer, like same model.
Yes, it's similar kind of concept. Yeah. Yeah, and we did that first in the live console, so about 7 or 8 years ago, and then System T was developed from that. So System T is a kind of dedicated broadcast console built on the same underlying technology. Yeah, I think the kind of big question that has been repeated a couple of times today is at scale. So how does a cloud console deployment at scale work, and how might that work in kind of public cloud, and I guess particularly with multi-channel and immersive audio? So I think I will share my screen if that's all right. I've got a couple of
Why not?
questions. So I just wrote down these questions, which hopefully you guys can see. You got that? Yep. So kind of, as I said, how does it work at scale? What's the kind of production model? That was the kind of starting point. What's the usage case? Let's talk to people about how they see it working. And then another part of it was, is the user experience going to be any different? Are they going to be the same as like using hardware? And then what else needs to happen, which is kind of, I'll hit that one first. It's been alluded to a few times. I think there's no point just putting the audio console there. You've got to put the communications, there's got to be the video, it's got to be a collaborative approach. At lower tier and smaller scale, maybe there's a one package fits all, but at the kind of larger scale, it's a bit more like building a broadcast facility. It's going to be the interaction of lots of different equipment. So it's good to see Mike kind of explain how the AMP works and the ecosystem has some bits to add to it. So I guess my first slide, I think, this one's pretty much been covered. It's a kind of view it as a progression and evolution of the remote production situation. So we had this traditional kind of on-site, take a truck to the venue, then there's remote production with the processing at the venue, a more centralized approach where you bring back everything back to a broadcast facility. Then it becomes a bit more distributed and you have different processing blocks or different control positions in different locations. And the cloud part of that, specifically public cloud, I kind of see as just the next stage of that, is to kind of move the broadcast hub part into the public cloud. So there's some questions about how you achieve that. And kind of, I wanted to explain a little bit of what System T's technology is today, just to kind of understand kind of the experimentation and the research that we're doing to see where it can go. That's kind of how I want to present it. So, as we just said, we've got x86 CPU audio processing. There's then this software thing called the audio control server, which holds all the kind of stateful information. So this holds all the kind of parameters that you might be controlling. And then there are multiple front panel software instances that can remotely control that. So you can do this with the hardware today, where a large format surface can control a rack mount of hardware processing. This large format surface can be remote, even across the internet, and the same in terms of a work from home scenario where the same software can run on a computer, again from home. So really what we're talking about in terms of cloud is lifting the main bits of this location one and deploying that on a cloud. That could be on-prem, or I think my opinion is target public cloud, and then the on-prem can kind of come with us with the same tools. There was a point earlier about the signals are already in the public cloud. That's the closest place to the venue. So that's kind of the main point to do. So I kind of took parts we have and kind of highlighted over in the right-hand side. Hopefully everyone can see that if they've not got Zoom pictures all over it. Kind of, these are what the requirements are to make this work in public cloud. So the software control, that's there. CPU-based audio processing. So I've already talked about x86. And I guess I should explain that, and it was mentioned earlier again about the concept of real time. What is real time? And a real time need for IFBs is very different from a real time to kind of mixing to someone at the mix position. So the way we do it on CPUs is we tune it to specific hardware, so specific motherboards, specific CPUs, and get that down into the kind of orders of 12 samples of in to out, including all the processing across a path. To make it more generic, you'd have to kind of slow that down a little bit. But in essence, that doesn't really matter because we're talking about public cloud. So that's not really a problem, but I just wanted to highlight a kind of difference there and difference in approach. And it might be a difference in approach with on-prem cloud and public cloud as well. I think the big key point for me really is the audio ins and outs. And there's been a fair number of kind of protocols briefly mentioned. I thought it was great the fact that it was brought up that kind of multicast in something like AWS, that's kind of not there. So we have to use unicast options. And I think maybe we're at a position where the kind of one standard to fit all scenarios isn't really going to work. And there's going to need to be a range of things supported. And because these are software, this doesn't really matter. So there's things like obviously people have said like NDI, SRT, RIST, RTP with FEC. Mark talked about CDI. So there's kind of a range of requirements from the getting audio in and out. And maybe some of those are different for contribution feeds than they are for distribution feeds. So I think the requirement is a flexibility and support lots of different variants there. I guess keeping it short, that's kind of all I had. So you got any questions? I don't.
Interesting. So it sounds like you're pretty far along on this, Tom.
I mean, I think we were already pretty far along in terms of the building blocks that we had.
Yeah.
So System T in itself was kind of developed with this in the back of our minds. This might happen. Obviously, there was a shift to audio over IP networks and routing infrastructure. And in a way, you could describe that as virtualized routing infrastructure. The software side was very much what software control. That's virtualized by its nature. And as I say, the missing kind of the extra pieces of the processing part, and then what are the system requirements of ins and outs? And I think they're more than just one company's choice. There are kind of the broadcasters have to plan the usage cases, and they probably will be a requirement for multiple different protocols. That's how I see it happening.
Well, and maybe some further standards development.
Yeah.
Well, I think we're going to probably have to hang it up here. This has really been, fascinating, and I think that there are so many issues that we've, and this is one of them that we've kind of touched on, that we need to talk more about issues like I/O. As an industry, we need to talk more about issues like I/O, and how do we feel about relying on NDI, or we're trying to get away from SDI, and now we're kind of back to trying to cram things into 16 channel blocks. And what's the long-term game plan? This has really been fascinating, and it's interesting. I think as I said, Dave Van Hoy and I started talking about this. When we started talking about this, there was nothing happening, and today has been so interesting to see everything that everybody's been working on, and really how people have different pieces of the solution, and everybody's it's just so interesting, and it's interesting to see the possibilities of this evolution. And Tom, I really appreciate the slide too of this is an obvious evolution. And in England, for Premier League or stuff like that, that's all gone away from the venue. It's gone to a broadcast center. And how is that really different from taking it to the next step of putting the broadcast center in the cloud? Then you may still have a full-size console sitting somewhere and a full-size switcher, control panel, and everything else. So I really appreciate everybody and everybody's, everybody who's stuck through this. And I'm interested in creating some other opportunities to talk with this group and other users who are interested in pursuing this. And I'll welcome, sort of any suggestions about when we do it or how often we do it or how we do it. And this has been a lot to get through, but it's really exciting to see everything everybody's doing. Sahara, you got any last words here?
Well, much of it echoing what you said. Many of us who have thought about it really struggled with how to make this happen, and it's good to see that people have been working on many of the different aspects, and I think now we can join together and hopefully push this much faster, because the market's looking for solutions, and I think it's up to us as some of the brain trust of the industry to really get the word out. As I think that's probably what we've lacked so far, is really getting that out to people and know that, hey, these solutions exist. Yes, they're still in development, but without people knowing about it, the production people, the executives, they are not going to okay the funding to move these projects. So I think that's our next task, is really trying to bring the industry together and get the word out of what's going on, because this is really exciting that there are solutions that exist today, and we can start moving some of these traditional workflows off of where they currently are and really move them to the future where they need to be. So thank you for everyone for participating, talking about the projects you're working on, because it was really exciting to me to hear the progress that many of you have made. So thank you.
Yeah, I absolutely agree, Tom. And this is one of those sort of rising tide lifts all boats. I think that we do need this sort of free exchange of ideas. And I know what it is like sort of battling the internal sale too. And so much of this sort of development has happened a little bit under wraps. And it's nice to sort of have a little, this kind of openness that helps us understand that we're all kind of heading in the same direction. We're not crazy about it being a direction worth heading in. So I think that's it. That's it for me. Thanks to everyone for showing up and sticking in. And this will be
Roger, thank you for organizing again.
Thank you,
What
Dave.
an incredible venue, and so incredibly commercially helpful in terms of getting out there, like Tom said, and getting people to actually take a try at it.
Yeah. Well, Dave, I really got to hand it to you, pushing the envelope on this one. So.
Crazy audio people with soldering irons.
Okay. Well, I hope the next time we get to talk more, we had a lot of ground to cover and everybody tried to be concise. It ran a little long, but we'll try to do better next time and try to leave some room for conversation. And we will have a DTV audio group meeting in Las Vegas at NAB as normal. I think it's on Saturday. So hopefully I'll see a bunch of you guys there. Okay.
We wish.
All right, you Europeans and Brits,
Go to sleep.
former United
Former
Kingdom
Europeans.
members. Thanks,
guys.
Rob. Thanks, Tom. Thanks, everybody. Thanks,
care.
Alex.
No.
Dark.
Roger.
Cheers, everyone.
All right.
Roger.